Okay, hello everyone. Uh, how was your quiz? Actually, there's a little problem. Like the first question, I think I had a typo, but it's still possible. But the solution is not necessarily because you need to solve concavity, right? Finding the concave upwards, which is the functions doesn't have any, right? But if you are able to find that, and you will get the full complete points. If you just compute and then maybe just guess which one is the having concave upwards, you still get a point. Okay. That's for number one. Maybe you'll feel like after when you try to solve number one, why I can't find the answer. Yeah, I'm sorry about that. But I think sometimes perhaps if you already take any project with professor or maybe in laboratory or maybe working in maybe internship, sometimes when you deal with the situations, you might deal with the not really ideal, not really like, okay, based on the book, it should be this, but in reality, maybe it's not the same. And you need to think how to analyze. Like your life is not like a textbook. It's something different. Sometimes when you have like a lot of skills, this is my personal experience with my Taiwanese friend. My Taiwanese friend, he is so predictable. I mean, he's really based on the textbook. Okay, you should do this. But then I said like, can we do this? And at the beginning, he seems like not really convinced in my opinion. But then, he is also like, for example, when you have something broken like electric, usually you find someone who understands, maybe calling the company, okay, I need to fix this. Maybe air conditioner. I think this is, very, very trouble. I think in my own experience, you have air conditioner. Maybe something needs to be fixed. You call usually the service, right? How much you pay? Thousands, right? You could fix that by your own, less than 1,000. Maybe not less than 500. And then I showed it to my friend and he didn't believe. And I showed him, I fixed this. It's easy. So sometimes we need to go out from the textbook and try to think by our own mind. And try to do that. And I believe when you learn maybe in industry, doing some project, you will learn that there's nothing that is ideal. Like you want to have a high salary. Maybe salary important, but not that important. You need to think other else. What benefit you get? Maybe experience, maybe something like that, right? So yeah, in exams, as long as you try your best, try to think out of the box, I can give you like a point. It's not always like the solution should be A, should be B, should be C. If you can have like E, that is logic and then convincing, it can be proven, I can give you points. Okay? Or it's original idea. That's what I like. Okay? If you can give that. Sometimes students, they do something like not really like the solution, like the textbook solution, but I believe it's fine, it's logical, and I can give points. Okay? You can try to do something like that. Sometimes when you like doesn't really know, but you know like, okay, I think I can do it. Maybe you need to use some formula, but then you decide to draw. It can be a solution as well. Okay? It can be a solution as well. And I can give you credits for that. Okay. Okay, now back to the topics. Okay. So your quiz, maybe next week I will deliver the result. I hope you can get at least half of the questions. Okay, maybe 50, 60, something like that. It's, I think, already okay. The quiz, why I need to deliver the quiz as early as possible. I also want to check your review on calculus, especially some techniques on integrations and derivatives. Okay? So that I know which level are you, and when the next quiz come, or maybe the midterm, I know what I can prepare for you. Okay. Okay. Now, it's still in chapter 10. We are going to see the polar equations. Okay. What's the idea behind this polar? Okay. So if you, I think, also in high school mathematics, I think. The polar equations, basically, we are going to first try to convert from the Cartesian xy. We are going to convert to, we usually write r and theta. So basically, this is, if you, I think you have a book like this in Taiwan, right? With rectangular pattern. Usually when you learn to write, you have books like this, right? So we say this is Cartesian. This is Cartesian world, okay? Because you move points by points in the rectangular patterns. Okay? And you can imagine maybe this is the y-axis, this is the x-axis. You can put y and x in anywhere, right, in this rectangular pattern. But now we are moving to here. So all the patterns that is rectangular will be changed, right? So we are having, so let's say this is, wait, let me use this one. Okay, now we are moving to this circle, so polar. So what's the deal? So we are going to identify the point. Let's say we are going to have like, let me draw an axis. This is called the polar axis, which is that. Okay, that in the middle. So this is the polar axis. So how do we identify this? Basically, we can identify by this radius of the circle. So we can, let's say this is 1, and then 2, and then 3. But it's actually, we can identify like in 1.5, 2.5, in any way, in any radius that we want. Okay? So that is r. And then we can move like that, and then change the angle. Okay? So that's why this is r theta. So from xy, okay, from xy to r theta. So we can have a figure like this. Let's say this is a point P. Okay, so you could relate to what we have here. So we have a polar axis, and then we have this radius here that we can change. Okay? We can change the distance. Okay, we can change the angle. Okay? And then to help you to navigate, we are always start from here. So the angle 0, this is the angle 0, and then move to the left. Okay? When you increase the angle. And then sometimes this happens. So when we have this, and then we move again, and then we can say that can this radius becomes negative? But sometimes we can write negative r theta. This negative r is actually r, but in the opposite directions, okay? By this plus pi. So if we plus this angle theta plus pi, it means that is equal to this. So this is equal to also, we can also say that this is also equal to r and then theta plus pi. They are the same. Okay, they're the same. Okay. This is important because if you try to draw some polar curves, sometimes you get, because sine and cosine, they can be positive, they can be negative, right? So if you get the negative parts, it means that when you try to move, it means that it is on another side. Or you can just plus pi, okay, plus pi like this. Okay. Okay, another one to change. So we need something to convert, right? We need something to convert. So we need to change from Cartesian to polar. I think there are only three that you need to figure out. First is this r cosine theta. Y is r sine theta. This is based on the triangle. And then the tangent theta is y over x. And then perhaps maybe the circle, if you can also substitute, then all these terms can be used to translate or to convert Cartesian polar, polar Cartesian. So again, in the polar, usually we have r theta. So if this is 1 pi over 2, it means the distance will be 1 and it will move with the angle pi over 2, maybe here. Okay. So conversion. Okay, next is what we call the, or maybe this one is for this one. I think we can move here, and this can be here. Okay. Okay, this is just conversion. Okay. Okay. Now, if we are taking the polar curves, okay. So I think polar curves I prepare on the next slide. So let me move for a while, and let me move here. So now we have the polar curves, which means we are in the polar system. Okay. So if we are, so polar curves usually we are having. So the polar curves is actually we are taking r equal function of theta. Okay. So if r equal a constant like this, so as you can see from what we have here, r equal to or r equal 1 in a polar system, it means a circle. So a circle with radius 1, circle with radius 2, and so forth and so on. Okay. And then aside from that, we might also get this, the theta. Okay. So if we have a theta equal 1, it means that we have a straight line. A straight line. So in radian, okay, this is in radian. So if not, then maybe theta can be using an angle like pi or pi over 2 and so on and so forth. And you will see we can rotate this, okay, as much as we want. It depends on the curves, the polar curves. But of course, this is two basic polar curves. Now the polar curves can be adjusted, can be drawn, and we can make it with a combination from sine, cosine. But I will go through one by one. Okay, now we can see here, I'll show you here. This is the r equal to cosine theta. Okay. Now for just observation, let's just plug in all the special value, right? Pi over 6, pi over 4, something that you can also remember, right? And then you see that we can have this value, okay? Now let's pinpoint in our graph, and notice that we have a negative. It means that either you need to plus the angle with pi, or you can just use the opposite directions. Okay? So if we set into our picture, the easiest way to draw is start from the polar axis here. Okay? Because that is when theta is 0 and the cosine is 1, right? So it has 2, 0, so r equal 2 and theta equal 0. Okay, and then I think no problem moving here, right? The square root of 3, you can, maybe if you draw with hands, try to just approximate estimation, okay, pi over 6. And then when pi over 4, it is square root of 2. And then I think it is still okay after you get until here, until pi over 2, because cosine is 0, right? So it's going back to here in the middle. But then, when we plug in the 2 pi over 3, when we move, we pinpoint at this, okay? Because this point is actually, if you see this is the opposite direction of this one right here, right? And 2 pi over 3 is precisely if you plus the I think not plus, if you take the other value as well, you can see the pattern. Okay. This one here, this one here, this one here, okay, and this one here. So no problem, it's a full circle, and we can see that we can get the full circle of the cosine. Okay. Okay, if you want to confirm that this is true, you could also try if you can change the sign. Okay. So do the same thing with 2 sine theta. Okay. So if you do the same thing here with the, let me move this a little bit up. Okay. So if you try to take r equal to sine theta, okay. If you try from 0, you will get 0. So you start from here, and then you try to increase your angle. I believe you will have like that, okay? Because at pi over 2, it's 1, so it should be something like this. Start from here, and when pi over 2, it goes through here. And then do the same thing when the r is negative. So it will have the opposite directions, okay? And it will symmetrical with the other points. Okay. Okay. This too will be your identifications. Whenever you see any cosine in the polar curves, it's a positive cosine. So positive cosine is always goes here. Positive sign always here. Okay? Negative cosine left. Negative sign down here. Okay? Because we are going to deal with the more complicated polar curves. But this will the same. This structure always the same. Cosine is left, right? Sine is top and down. Okay. So if you see the differences, so this will be, let me draw here. So this is for negative. Okay. And the constant can be any constant. It means that if we increase the number, it will be bigger. Okay. Or if you want to write maybe with just a, maybe we can write with just a. A is a constant. Yeah, I think difficult to draw in paper, right? If you are using digital one like me, you could make some chip and draw a circle perfectly. This is r, negative a sine theta. Or maybe I'm using the green one here. And then a is a constant. Okay, that's the first, I think, polar curves. Now, what will happen if we have r equal 1 plus sine? So any numbers that you get from sine, then you need to plus 1. You could think sine has a maximum 1, right? So the maximum of this is 2. But then sine also have a negative 1, right? So it's 0. So it's not a first circle. The other circle will be touching 0. So it's like a fruit, right? Can you imagine it? So if the sign like this, then if we plus the negative with 1, the negative one with 1, it will be 0, right? So perhaps it will be something like that, like a heart but upside down. Okay? And we can try it. We can try to draw that ourselves. As long as we consistent and proportionally correct. Not to like you. It doesn't need to be perfect. As long as proportional, I think it should be okay. Okay, let's try here. So we could start from. I think we could start from just take sometimes to check the value. Okay, to check the value. So we take the value. So Make it here, make it there. So if we take 0, so let me write here, this is r equal 1 plus sine theta. And then let's check from 0 to 2 pi. This is for theta, this is for r. Okay, so we can just evaluate each value. So if we take 0, r will be 1, so let's say 1 is here, and this will be 2. Oh, why it's missing? Okay, and then this will be maybe pi over 2, pi, 3 over 2 pi, and then this will be 2 pi. Okay, just draw like a normal sign, but we need to plus 1. It means we are going to have the maximum on pi over 2. So let me draw pi over 2 here. So it would start from there. Oh, it's not, doesn't like to be a little bit curvy. And then when sine is -1, I think when theta is pi, it's 0, right? But plus 1, so it should be equal to here, so it goes down there. And when sine is -1, which is here, right? And then it goes up, and then reaching the 1. Okay, I believe that is our value. Okay, according to this value, then we could try to make out our graphs of 1 plus sine in a polar, right? In a polar. So we could start with maybe trying to make the polar axis first. Okay, so this is theta equals 0. And then at theta equals 0, r is 1. So let's make that. So 1 maybe that. Okay, then this is 1. Or maybe not. Maybe just mention this is 1. Okay. Oh, why? Why sometimes it's missing out. Okay, and then we try to increase, let's say here, let me use different color. This is theta equal pi over 2. So suppose that the pi over 2 we have, this is 1, this is 2. Okay, since all will be a positive, right? So we are going to take 1, and then maybe you could try some angle between like pi over 6 or pi over 3. Okay, maybe pi over 6 to make it half, right? Half plus 1, 3 over 2. So when pi over 6 maybe around here, so the length, I'm just estimating, maybe over here, okay? Because it's one half, right? So maybe over here will be the theta equal pi over 6. So this one, okay. Okay, and then we see that if you try the other one also, you will get that this is going to be like that. Okay. And then you will see when you increase again, maybe between pi over 2 to pi, you will see that it is going to decrease. So you will see that from 2 it will decrease, and at some point that is complementary with the pi over 6, it will have a symmetry, right? It will have a symmetry. We will have a symmetry Okay, and then what? And then this is pi, this is pi. Okay. And then from pi to 3 over 2 pi, okay, we still have this, right? So we need to take this. So it's getting smaller, right? It's getting smaller from here to here, it's getting smaller. So imagine that we have 1 here, but it's getting smaller. But eventually, at the 3 over 2 pi, it is 0. So it's getting smaller, and then exactly reach this point, okay? So it's going to be a different color. Like that. And let me erase this one here. And then do the same thing from 3 over 2 pi to 2 pi. Because this is, they are symmetrical, same value. So this one should be symmetrical. Okay? Okay. This is what we call the cardioid. And how to know, because cardioid has many, many variations. It can have this, it can have cosine also. But remember, if you remember what I told you before, cosine right, minus cosine left. Positive sign on the top, negative sign on the bottom. This is positive sign, but it's cardioid, but it's largely on the top. So if you have one minus sign, it will be, okay? You get it? It has a pattern. Should be easily to be found. Okay. So and there will be some pattern on the formula also, but I think I will give you at the end. Okay. If we still have time. Okay. Another curve that is interesting is the flower curve, the rose curve. So this is the cardioid. So cardioid generally have is A plus minus B sine theta, or A plus minus B cosine theta. A and B are constants. And the ratio between A and B will determine which cardioid. It can be this, or it can be something that has a loop here in the middle. Okay? Or it can be almost a circle but not yet circle. Okay? It can be several forms. Okay? But if you have A equal B, or the ratio A over B equal 1, you will have the heart shape. Okay, the heart shape. Okay, so the next one, let me go for the curve R cosine 2 theta. So as usual, we can sketch this based on the value. So we can sketch the value first. So x-axis as the angle, and then the y-axis as the value. R. Okay, now cosine 2 theta. I think we can agree that the maximum is 1, right? And the minimum is -1, right? So we could start, maybe I will move this to here, okay, and this. So we can start taking 1 here and -1 here, and then we could start Usually we say when it's pi over 4, it's pi over 2 because of these two. So we could take by 4, okay? Pi over 4, pi over 2, okay? So this will be pi over 4, pi over 2, and then 3 over 4 pi, and then pi, and then 5 over 4 pi, and then it's 3 over 2, and then 7 over 4 pi, and then 2 pi. Okay. Okay. Cosine is 0 when it's cosine pi over 2. So when it is pi over 4, right? So from this 1 here, when it's 0, so it will goes down. Okay. And then cosine will be negative when it is pi, right? Cosine pi. So when pi over 2 is negative 1, right? So we could see that it will going down like that, okay? So let's draw. Okay, and since the sine and cosine, they are having the same all the periods, they have the same amplitude, so we could replicate this, and then we could take this, okay, and then get over there, and then going down again, right, and then going there, 0, and then we have something that is on 2 pi is getting value equal 1. Okay. Now based on what we have, now we must be careful when we draw this into the polar because we have the negative 1. Okay. Okay. Now we take this into the polar. Okay. But let me just draw this just to denote that this going to be theta equals 0. Theta equal pi over 2, theta equal pi, and theta equal 3 over 2 pi. Okay, I think we can start from this, right? From 0, this 1 here. Okay, we can start from that point. And start from, let's say this, okay? And then as we move through pi over 4, so let's say pi over 4 is practically in the middle there, right? So I think I can also draw a curve, maybe this, okay? I think it's better to have this, right? So that we can be sure for the angle. This is theta equal pi over 4. Then this will theta equal 3 over 4 pi. This is theta equal 5 over 4, sorry. 5 over 4 pi. It's 7 over 4 pi. Okay? So as we move from the 0 to pi over 4, you will see that it's actually going down, right? The value going down. So at the pi over 4, so it's going down, it means that the distance is also going to shorten, and then it's going to reach 0. Okay. So we get that. Okay, that is our first curve, right? From 0 to pi over 4. Okay. And then what's happening now? We are going to down here. It's negative 1. So we are going to move to pi over 2. Pi over 2 are over here. Okay? So if we use our intuitions, we need to have something here. But remember, it's negative. Okay? It's below 0. Which means when we are going to here, no, it's opposite direction. Go here. So that's our curve. Okay? Get it? Okay? And then we move this to there. Okay. Okay? And remember, this is not the angle that is in between this. This is from the pi over 2. Okay? Okay. And then what's happening? From the pi over 2, we move out to 3 over 4 pi, which is it's going to increase. So from pi over 2, but it's still negative. So to give you some idea is, let's say pi over 2 and 3 over 4 pi is here. Right? So we move here, but it's still negative. So the direction should be this one, the opposite direction. Okay. So we move again up until when we get the 3 over 4 pi, which practically that one. Okay. Okay. Negative parts over is now positive. Okay. Now positive, we start from 3 over 4 to pi and then 5 over 4. Okay. So from 3 over 4, 3 over 4 is here. And now we are now in the same direction with this. And then it's going here. And then it's going here. And then you can see that it's all the way back to here. Okay. So from here, you will get this. Sorry. Okay. That one. And then still on the same, you will get that. Okay. So that is the 5 over 4 pi. So back to 0, right? Back to 0. But then negative again. So 5 over 4 is here, right? So it should be around here. But now we are going to have opposite direction. This, here, right? So here goes to that point. Okay? So we go here. And that. So this pi over 2 is actually not pi over 2. This curve is meant to be 3 over 2. Okay. This one. That's the opposite direction of 3 over 2 pi. So that means here. Okay. And then from here, still negative, but then going to be 0. So it should be here. Which is actually from here, we mirror to this one. So this opposite direction. And then finally close to that point. Okay? Okay, now we say this is the 4-leaf rose. Okay. Okay. So from this one, go down. So far so good? Okay. Okay. Now this one here is the another form. I think the same form like the what we did before, the cardioid, but with its family member. The general name is the limazon. What's the meaning of limazon? It is Spanish? Okay. Okay. So I think will be the end of our lecture. But you could just see if we have the 1 plus, okay, 1 plus c sine theta, and you can see when we have 2.5, 1.7 equal 1, we did this before, 0.7, 0.5, 0.2. This is what is similar to what I've telling you before, a plus b sine. Okay. We can also write 1 plus c, then c will be a, like a will be b over a. And we could see that when it's negative, it starts, so it's 0, and it's starting going down, going down, going down. It's larger on the bottom. Okay. So see you next week. We are going to continue this part. Okay.